Okay, so hopefully you just watched that video about how to tell if a set of ordered pairs is a function and how to tell if a mapping diagram is a function. A friendly reminder that our function definition, our basic function definition, is that we cannot have any repeating x values. So I capitalize x value because we can have repeating y values. That's okay, but we cannot have repeating x values. Definitely not. That's like the main core of what makes something a function. So it doesn't have any repeating x values. So what's nice about tables, and we've kind of already talked about this, right, is that our x's and our y's are already separated out for us, so we don't have to go like hunting for them, kind of like we have to do with a graph. So the main thing that I do when I'm looking at these is I just go ahead and scan through my x column here, and I'm trying to look and see, do I see any repeating, oh, that's not helpful. There we go. We're trying to look and see, do we see any repeating x values in here? So let's just look and see. Okay, I have a positive 2, I have a positive 3, I have a negative 2, I have a negative 1, and then I have another negative 2. So since I have two negative 2's here, that means that I have repeating negative 2's. So that means that this is not a function. No, not a function because of these two. If we look at number 8, look at our x values again, looking at our x values. We have a positive 1, a positive 2, a positive 1 again, and another positive 2. So I have repeating x values all over the place here. I have a repeating 1, and I have a repeating 2. Let's see if we can maybe show that. Excuse my messy drawing. So because I have a repeating 1 and a repeating 2, that means that no, not a function. If we look at this one, number 9, and these are all in your practice packet. Sorry if that wasn't clear, but they're all that first page of your practice packet. Our x values, let's see. I have a 0. Cool. Negative 4, 3, 2, and 1. None of these are repeating. So that means that yes, it is a function because I have no repeating y values. Let's look at the graphs now because graphs are a little weird, I think, sometimes. So the way that repeating x values show up on a graph is that you have 2 points that are directly on top of each other. So let's just dive into number 10 here, because this is a really good example of what we don't want to see. If you look here, this point right here, let's see if I can circle it, which is 1, 3, and then this point here, which is 1, 5, 2 ways we can analyze this. Whoa, not like that. Both of these points, their x values are 1. So since both of these points have an x value of 1, we know that they have repeating x values just by that. So repeating x value of 1. We can also look at this because these 2 points are right on top of each other. Or let's not say it that way. 1 point is graphed right above the other one. Since 1 point is graphed right above the other, that means that they have the same x value. Means they have the same x value, which means that this is not a function, right? Now let's kind of go out of order a little bit. This is number 10. We're going to jump down to number 13. But we're going to jump down to number 13 in a different video because I'm out of time. All right, talk to you soon.